In this video we're going to be looking at solving simultaneous linear equations by cancellation. There are three different types where there's no multiplication needed. I'm going to do two examples. Where there's one multiplication needed, I'll again do two examples. And finally where there are two multiplication needed, and I've got two more examples. So if we have a look at the first one, the way I always do simultaneous equations, and I think the best way of doing it to label it correctly is if you label each equation number 1 and number 2, and then we can say what we're doing from there. There's no multiplication needed, so we just need to add or subtract the two equations to eliminate one of the variables. We've got an a and a b. We need to get rid of one of them to find out. If we got rid of the b terms, we'd know what a is. If we got rid of the a terms, we'd be able to find out what b is. Here the coefficients of a are the same, so we're going to be able to get rid of the a terms. Once the coefficients are the same, we can get rid of them. Here these b coefficients aren't the same, so we can't. So a and minus a, we're going to have to add them together. So if I do equation 1 plus equation 2, a plus minus a is just nothing, and then 4b plus 7b is going to be 11b. 18 plus 15 is 33, so b is 33 over 11, so b is 3. Once we've got that, we then need to just substitute that b equals 3 into one of the equations. I'm going to substitute into the first one because it hasn't got any negative terms in it. So I'll have a plus 4 times b, which is 4 times 3, which is 12, equals 18, and then just solve it like a normal equation, subtract 12 from both sides, so a is 6. So we've got our two solutions there. Here on the next one, the y coefficients are the same, and positive 2y and positive 2y, if we add them we'll get plus 4y, which we don't want. We want to get rid of them, we want to make 0, so instead we're going to subtract equation 1 from equation 2. And the reason I'm doing 1 from 2 is because 4 minus 3 is going to still be positive. I could do 2 minus 1, but that would give me a negative x, and I don't really want to work with that if I don't have to. So 1 minus 2 is going to give us x. 2y minus 2y is 0. 23 minus 18 is 5. And then we're going to substitute that into one of the equations. So substitute x equals 5 into, let's do it again into equation 1. It doesn't matter which one we substitute into. So 4 times 5 is 20, plus 2y equals 23. So subtract 20 from both sides will leave us with 2y is 3, so y is 3 over 2. Those are our two answers. If we're not sure, we can always check our work. It's a good idea to do this, and the way that we do this is just by substituting them both in. So we used equation 1 here, so now we need to check in equation 2. So if I multiply 3x, which will be 15, so this is for equation 2, so we'll have 15 plus 2 times 3 over 2, which is going to be 2 times 1.5, which is 3, equals 18. 18 equals 18. That makes sense, so it means we've got the right answer. Let's move on to where one multiplication is needed. So that's where none of the coefficients are the same, but we've just, by multiplying one of the equations, we'll be able to get the coefficients the same. And the way that we're going to be able to do this is if we multiply 2 by 4, because then that will make the y coefficients both 4. Multiply this whole equation by 4. It's going to give us a third equation, which will be 8x plus 4y equals 40. I'm going to call that equation 3. Now we're going to get rid of the y's because they're the same. This 4y is the same as that, so we can subtract those, and I'm going to do this one, take away that one, so that we're left with a positive value of x. So we're going to do 3 minus 1, which will give us 5x equals 40 minus 20, which is 20. So x is 20 over 5, which is 4. And then we're going to substitute x equals 4 into one of the equations, preferably one of the first two rather than the third one, just in case we've made any mistakes. I'm going to substitute it into the second one this time. So going to have 2 times 4, which is 8, plus y equals 10. So subtract 8 from both sides, y equals 2. Those are our two solutions. You might be wondering what these solutions are all about. The reason, well, what they are essentially are coordinates, and what we have are two graphs. If I was to show you, or just to generally sketch them, essentially what we have is, if we rearrange this equation here, we have y equals 10 minus 2x, which is going to be quite a steep line going down like that. And if I was to sketch this one, rearrange it, we'd have 4y equals 20 minus 3x. So y is minus 3/4 x plus 5. So it's going to cross at 5, but it's going to have a much shallower gradient. So it's going to go something like that. And so the coordinates are this crossing point here. So it crosses at when x is 4 and y is 2. So that's the coordinate of where the two graphs, where the two lines meet on a graph axis. Moving on to the second example of this type. Again, I'm just going to label 1 and 2. And again, we can multiply by 4 here to get 4t. So I'm going to do 2 times 4, which is going to give us 8p minus 4t equals 12. Call that equation 3. And then we're going to add the equations this time, because if I add them, it's going to eliminate the t's. If I was to subtract them, I'd have 4t minus 4t, which gives us positive 4t, or if we did it the other way, minus 4t minus 4t would give us minus 8t, and we're not actually getting rid of it there. So we're going to add, so we're going to do 3 plus 1, which is going to give us 11p equals 20 plus 12, which is 32. So p is 32 over 11. Just realised that this is incorrect here, this question. I've written it down wrong. That should be 10, which means that this will be 22. So 22 over 11, that's going to give us a much nicer solution. 22 over 11 is 2. And then if we substitute that into one of the equations, let's substitute it into equation 2. Even though it's got a negative in it, you can just try and deal with that. So 2 times 2 is 4, minus t equals 3. Subtract 4 from both sides, minus t equals minus 1. Multiply both sides by minus 1, t equals 1. In the final type of example, there are 2 multiplications needed. So again, we're going to call them 1 and 2, but this time we need to choose which ones we're going to make the same. I'm going to make these two the same, so I'm going to have to multiply them both to get the same coefficient. I want the lowest common multiple of 3 and 4 is 12, so I'm going to do equation 1 by 4 and equation 2 by 3, which is equation 1 is going to give us 16x plus 12y equals 4 times 15, which is 60. And then for 2, I'm going to get 15x minus 12y equals 11 times 3, which is 33. And now label them equation 3 and 4. And because this one's positive, this one's negative, we're going to add the two equations. So we're going to do 3 plus 4, which will give us 31x equals 93. So x is 93 over 31, which means x is 3. And then to finish it off, get the y coordinate. we're going to substitute x equals 3 into one of the equations. I'm going to do it into the first one so we avoid any minuses. So 4 times 3 is 12, plus 3y equals 15. Subtract 12 from both sides, so 3y equals 15 minus 12, which is 3. Y equals 3 over 3, which is 1. And then finally the last one, again, I'm going to label them equations 1 and 2. I'm going to multiply both equation 1 and equation 2. I'm going to multiply the a terms, and the lowest common multiple there is going to be 6. So if I do 1 times 3 and 2 times 2, so we'll get 6a for the first one, plus 3b times 3 is 9b, equals 48. And then for the second one, 6a plus 8b equals 46. I'm going to label those 3 and 4. Because they've got the same, they're both positive, I'm going to subtract. 9b minus 8b will give us a positive answer of b, so I'm going to do 3 take away 4, which will leave us with b equals 48 minus 46, which is 2. Then we're going to substitute that into one of the equations. Let's do it into the first one. So 2a plus 3 times b, so which is 3 times 2, is 6, equals 16. Subtract 6 from both sides, 2a equals 10. A is 10 over 2, which means that a is 5. So those are our two solutions there.